I told you yesterday, electrophilic substitution takes place at position number 5 and position number 8. First reaction, that is halogenation reaction, is an example of this type. Okay, this is your quinoline. It has to undergo halogenation reaction. So to halogenize quinoline, let me put a halogen called as bromine in the presence of oleum. Heat it. I said 5 and 8. So this is going to give rise to two products. Position number 5 is 1, 2, 3, 4, 5. So my bromine will come and sit over here. In the other possibility, you will have halogen sitting at the 8th position. So this is your quinoline and 8th position is over here. Okay, it can be a mixture of both, 50-50 percentage. Okay. Halogenation is clear. Second electrophilic substitution is basically comprising of addition of nitro group using concentrated sulfuric acid and concentrated nitric acid. Okay, I'm ready. Now this is concentrated H2SO4 and concentrated nitric acid. Heat it. This is also giving rise to two products. Again, positions number 5 and position number 8. Over here is my nitro group. Fine. Now, these are electrophilic substitutions. Let me now talk about the nucleophilic substitution, in which the positions matter. This was first, this is the second. I'm talking about nucleophile. So 2 and 4 are the positions which will be occupied by the incoming nucleophile. And a classic example is nothing but your amination reaction. Amination reaction. I will divide it into two parts. Let me speak about minus 66 degrees Celsius at one arrow and minus 40 degrees Celsius on another arrow. All the reagents will remain the same. I will have to use soda amide. I will have to use ammonia. Again, I have to use soda amide. I have to use ammonia. But the products now synthesized will be different. When you are using very, very low temperature like minus 66 degrees Celsius, the substitution takes place at the second position. Substitution takes place at the, this should be here, at the second position. So this is 1 and this is 2. So my amino group will come and sit over here. Now you are using a little bit higher temperature as compared to minus 66. You are using minus 40. So the product will now be formed, will go to position number 4. This is the position number 4. Okay. So what are the names? This will be 2-amino quinoline. This will be 4-amino quinoline. Isn't it very simple chemical reactions, right, everyone?
Yes, ma'am.
So I will recapitulate it to you once more. I'm talking about quinoline. Quinoline undergoes electrophilic substitution at position number 5 and position number 8. Good examples of electrophilic substitution is halogenation and nitration. So let us see an example. Halogenation of quinoline with bromine in presence of oleum is giving rise to a 50-50 mixture of 5 bromo and 8 bromoquinoline. Next example of electrophilic substitution is using nitrating mixture, that is a concentrated nitric acid and sulfuric acid. This is going to give me again a mixture of two products, nitro at the 5th position and at the 8th position. So again, this will be a 50-50 mixture. Okay, the product will be 50-50%. Now I am talking to you an example of nucleophilic substitution reaction where the positions will be changed. For nucleophile, you have to keep in mind it is position number 2 and it is position number 4. A good example of nucleophilic substitution is amination. I am going to use same reagents, but only the reaction conditions will differ. At one particular point of time, I am using minus 66 degrees Celsius, and another point I am using minus 40 degrees Celsius. In both the cases, I will be getting two different products. When your reaction condition is extremely low, you will get a substitution at position number 2nd. And when you are slightly higher than minus 66, that is at minus 40, you will be getting a product at 4th position. Is this much very clear to everyone, bacha log?
Yes, ma'am.
Yes, please take it down.